Hello, everyone. Good morning. To authors and invited guests, welcome to Technical Session 5C. Myself, Ishita Sauryan, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 9th International Conference on Information Communication Technology for Intelligent Systems, ICTIS 2025, Bangkok, Thailand. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Bangkok, Thailand, and the virtual event is being held through Zoom today and tomorrow, that is 5th and 6th of April 2025. I hope you will all enjoy the knowledgeable interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answer. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you stay connected with us to the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session. We have with us Dr. Aarti Milan Karande. Dr. Aarti is an assistant professor at Siddharth Patel Institute of Technology, SPIT, with extensive experience in the higher education sector. She possesses expertise in enterprise architecture, software audit, personality development, databases, object-oriented programming, and application servers. Dr. Karande has a strong research profile with publications in 27 international conferences and 15 international journals, reflecting her commitment to academic excellence and innovation. She has also presented her research in a variety of fields, including machine learning and artificial intelligence. We welcome you, ma'am.
Good morning, and thank you very much for such a nice organization, and see you for the good thing. Thank you.
Thank you, ma'am. We also have with us our session chair, Dr. Priyanka Sharma. Dr. Priyanka Sharma is a professor and director of research and development in Raksha Shakti University, Ahmedabad, India. With 18 years of teaching experience and 6 years in research, she has published extensively in reputed journals, included India Science, IEEE, Springer, Elsevier, and Taylor and Francis. She is also an active member of the editorial boards of various academic journals. We welcome you, ma'am. Now I would like to start with the paper presentations. I'd like to invite a first paper presenter for the session.
Hello, good morning.
Yeah, good morning.
And looking forward for the presentations. Okay,
Sure,
let us start. Okay.
Our first paper presenter for the session, Meghna Puwari, with the paper titled A Comprehensive Survey of Generative AI Agents, Transforming Predictive Demand Forecasting and Supply Chain Optimization Strategies. Ma'am, if you're ready, then you may start with the paper presentation.
Yeah, we have like 4 to 5 authors in our paper. We'll have one of the authors start sharing the screen and present it.
Sure, ma'am.
अलग अलग जना प्रेजेंट કરે એટલે મેઘના પોવાડી પ્રેઝન્ટ નહીં કરતા મેઘના પોવાડી નથી કરતી કરે છે સ્ક્રીનશોટ બીજાએ કરી સ્ક્રીનશોટ આદર્શે કરી
Hello, Adarsh.
Athav will start.
Yeah, go ahead.
Okay. Hello. Good morning, everyone. It is wonderful to be present here at ICTIS 2025. Our presentation today is titled A Comprehensive Survey of Generative AI Agents, Transforming Predictive Demand Forecasting and Supply Chain Optimization Strategies. This work aims to examine how generative AI agents are revolutionizing predictive demand forecasting and supply chain optimization. As more industries are relying on AI-based solutions, it is essential to understand the strength, weakness, and potential future of such agents. Before we venture into the subtleties, let me introduce our research team. This is a collective effort of a group from different organizations. I am Atharva Raut. We have our team. uh, uh, Meghna Puwadi, Sai Sheshu Sai, and Harshvardhan Puwadi, who work together extensively on consolidating knowledge. In this session, we will present the major conclusions of our survey, the decision-making implications of generative AI, and the challenges that needs to be overcome for its successful application in real world. Uh, Next, please. Okay. So in this uh, in this session, we will cover the introduction, problem statements, hypothesis, background and evolution, implementation, result, challenges, conclusion, and recommendation. Next, please. Okay, so now let's start with introduction. Why AI in supply chain? So traditional supply chain often struggle to adapt to dynamic environments. Market fluctuations, unexpected disruptions, and demand variability make it challenging for conventional methods to ensure efficiency. This is where AI plays a transformative role, enhancing decision making, improving forecasting accuracy, and enabling supply chains to respond in real time. Next is challenging traditional methods. Historically, supply chains have relied on rule-based heuristics, which are often slow, rigid, and inefficient when dealing with large-scale operations. These methods lack adaptability, making it difficult for business to optimize logistic and resource allocation effectively. Uh, our research objective is we aim to explore how AI-driven generative models can be leveraged for real-time demand forecasting, supply chain allocation, and revenue optimization. Uh, Next, please. Okay, so tradi- let's talk about the problem state. Traditional supply chain management relies heavily on historical patterns and rule-based approaches to make decisions. While these methods have been effective in the past, they present several limitations in today's unpredictable business environment. A rigid and reactive system. Uh, Traditional models primarily use data and predefined rules, making them slow to adapt to real-time changes. Inefficiency in handling disruptions, sudden changes such as demand fluctuations, supply chain disruptions, and logistic constraints create bottleneck that traditional methods struggle to resolve. Lack of real-time decision making. Conventional supply chains lack the intelligence to make proactive and data-driven decisions, leading to inefficient resource allocation and overall performance. For example, the COVID-19 pandemic highlighted these limitations when global supply chains face severe disruptions. Companies that leverage AI-based forecasting tools such as Amazon managed to quickly adjust procurement and distribution strategies to mitigate supply shortages. Next slide, please. Now let's talk about the research hypothesis. Research hypothesis that AI-powered supply chain shows that AI-powered supply chain models significantly enhance the adaptability and profitability. It highlights two key AI-driven advancements. First, AI-based forecasting, which improves demand prediction accuracy, reducing fluctuations and preventing supply chain disruptions by analyzing historical data and real-time market trends. AI helps businesses anticipate changes in demand more effectively. The next one is AI-driven optimization. Enhances resource allocation by automating decision-making processes, ensuring efficiency in inventory management and logistic coordination. Our study found out that AI-driven forecasting reduces demand-supply mismatches by 30% in the retail sector, helping companies reduce waste and improve fulfillment. Next slide, please. Okay, so now the background and evolution of supply chains. says that the transition from traditional methods to evaluation systems, it highlights three key areas of transformation. First, the traditional supply chain relied on historical data and rule-based decision making. Uh, Second, AI's role in modern supply chain, which introduces machine learning and generative AI by enabling real-time optimization. Finally, the key elements of AI-based supply chain include demand forecasting, revenue optimization, ensuring business that can better predict market needs, allocate service efficiently, and maximize profitability. For the okay, next please. For the next slide, Meghna ma'am will present.
Yeah. Actually, in the interest of time, I'll quickly jump into the implementation. Can you move to the next slide, Adarsh?
Yeah.
So I'll focus on the key parts of our survey. This diagram highlights the implementation of LLM-based industry solution for supply chain optimization. The system integrates with a text to SQL model that translates natural language queries into database queries. Internally, it has data over demand, supply allocation, the parts within the entire ecosystem, and the pricing details. The retriever component assesses the historical data and documentation, which provides the context for decision making. And at the heart of the system is manager agent, which serves as the orchestrator, decomposing complex supply chain problems into specialized tasks and coordinating between different AI agents. These specialized agents include the first one, as you see, is the modeler agent. Modeler agent translates the business requirements into mathematical models for optimization. For example, when a planner asks something like maintain 98% service level while minimizing holding costs, the modeler agent can decompose it into multiple subproblems and then pass it on to the coder agent and the linear optimizer agent, such that it can do appropriate safety stock allocations, stock calculations, reorder points, and inventory positioning across the network. The coder agent is more like a utility which generates implementation code for internal mathematical calculations and conversions. The optimizer is a linear optimizer which executes optimization algorithms to find solutions for supply allocation and inventory management. The interpreter agent basically translates these technical results back into natural language in the form of structured tables and meaningful sentences, which makes the AI decisions and recommendations understandable to human decision makers. This whole implementation significantly enhances the adaptability in dynamic market conditions, as Athar earlier was saying. And it has seen notable improvements in companies like NVIDIA, up to 15 to 20% for order fulfillment, and 10 to 15% in revenue optimization compared to traditional methods. This implementation is powerful because you can simulate hundreds of potential responses to disruptions in minutes without needing multiple days and Excel sheets to make the decisions. I'll move on to Adarsh so that he can quickly cover conclusion.
Let's explore three key aspects of implementation. Advanced AI integration enhances real-time data utilization through retrieval augmented generation. By leveraging SQL-based automation, this system efficiently requires supply, demand, and pricing information, ensures precise and time decision making. Optimization resource allocation is achieved through collaboration of modeler and coder agent. These agents dynamically adjust supply chain parameters, while an executor service ensures rapid response to market fluctuations, maximizing operational efficiency. Human AI collaboration plays a crucial role in bridging AI-driven insights with human expertise. Interpreter agent delivers real-time analytics, empowering supply chain manager with actionable intelligence for faster and more informed decision making. Results. Further discussing AI's impact on operational efficiency, let's examine two key areas. Performance gains with AI. AI-driven solutions contribute to 15-20% increase in order fulfillment by optimizing logistics and demand forecasting. Business experience 10 to 15 revenue growth through enhanced decision making, while AI enables 20% plus improvement in handling demand fluctuations, ensuring greater adaptability in supply chain operations. AI versus traditional methods. While Compared to traditional rule-based methods, AI models significantly outperform conventional approaches by leveraging real-time data processing and predictive analysis. These advancements results in accurate forecasting, improved resource allocation, and a competitive edge in dynamic market condition. Conclusion: AI-based supply chains enhance efficiency, adaptability, and real-time decision-making, driving competitive advantages in dynamic markets. However, several challenges must be addressed. Challenges remain despite advancements. Model interpretability remains a concern, ensuring transparency in AI decision-making. Scalability issues pose hurdles in expanding AI-driven solutions across complex supplier network. Additionally, ethical considerations in AI-driven pricing models necessitate responsible implementation to ensure fairness and compliance. To overcome these challenges, focus must be shifted towards developing adaptive, interpretable, and ethical AI models that balance efficiency with accountability in supply chain operations. Research findings. Our research highlights three critical challenges in AI implementation: data reliability. Incomplete and biased data can reduce the reliability of models, leading to inaccurate predictions and suboptimal decision making. Accessibility constraint. The high cost of AI models creates barriers to widespread adoption, limiting their use to organizations with substantial resources. Transparency issues, lack of explainability in AI decision making, trust and slow adoption, as business and stakeholders require clarity on model outputs. Challenges. To fully harness the potential of AI, we must address key challenges. Data quality issues. Incomplete and biased data can reduce model reliability, necessity improved data collection and validation techniques. Computational constraint. The high cost of AI models limits accessibility, requiring strategies to optimize computational efficiency and lower cost. Model interpretability, lack of transparency hinders trust and adoption, making it essential to develop AI systems that provide explainable and interpretable outputs. Uh, Research study from our study shows that explainability remains a major barrier to AI adoption, as seen in AI-driven dynamic price models, where transparency concerns have led to regulatory scrutiny. Recommendations. To maximize the effectiveness of AI in supply chain and business operations, we propose following recommendations for researchers to explore the development of self-adaptive AI models capable of adjusting uh, to uncertain and dynamic environments. For industry to strengthen human AI collaborations to enhance decision making, leveraging AI insights while maintaining human AI oversight, prioritize sustainable AI driven supply chain optimization to improve efficiency while minimizing environmental and ethical concerns. Uh, Companies like Siemens have successfully integrated human AI collaboration in supply chains, allowing human oversight on AI generated insights to ensure ethical and practical decision making. These steps will bridge the current challenges and drive AI innovation forward. Uh, Thank you.
Would you
Are
like
there
to ask any question?
Good morning. Am I audible?
Yes.
Yes.
Yeah. This was very interesting topic, which I think you have highlighted over here. I want to understand when you are talking about different agent at different stages of your proposed system, how they are working. Like, have you implemented this, or this is just a proposed idea?
This is a survey of industry implementations that we saw, ma'am. In terms of like, we took 3 approaches that was implemented by different companies like NVIDIA, Siemens, and few others. And then we drew the common patterns of these agents that they implemented for both optimizer and modelers. And then we drew the reference architecture based on their implementations from the public industry material as well as the research material.
So it means it is just a proposed idea. It is not implemented.
Yeah, they implemented, like these companies have implemented and published that material. So ours is mainly the survey of how these models worked in tandem.
Okay. Then what you are trying to say here by using a word called as an agent?
So these agents consist of the prompts and output parsers, integration with the database schemas, and the few short examples. That's the agent part.
Okay. So are you using any technique which is specified under AI?
Mostly prompt engineering and the large language models, which are Llama 3.170B.
Okay. Good work. I will like to see more enhancement in this proposed model. Best of luck.
Thank you.
Thank you, ma'am. I'd like to invite our next paper presenter for the session. Paper presenter Charmaine Pune with the paper title Fill Shield Harmful Query Detection in Large Language Model for the Filipino Language. Ma'am, if you're ready, then you may go ahead with your presentation.
Hello, good morning. Can you hear me?
Yes, ma'am, you're audible.
I cannot share my screen.
You can share it now. I stopped sharing my screen.
Okay, thank you. Hey, good day, everyone. I am Charmaine Esponay from the National University of the Philippines. And with my co-author, I'm going to present our research titled Field Shield, a harmful query detection in large language model for the Filipino language. This is the outline of my presentation. I'm going to start with the background of the study, followed by the research problem, the methodology, and the conclusions and recommendations. Let me discuss brief background of the study. So AI safety focuses on preventive measures against accidents, misuse, and other harmful consequences of the use of artificial intelligence applications. Research from groups of scientists, data analysts, and other related fields like ML Commons, Stanford University explores different methodologies in creating models, which aim to detect safe or unsafe LLM responses, as well as benchmarks, which evaluates how commercial and open LLMs respond against adversarial prompts across several risk categories such as intent to harm, harassment, abuse, and so on. Research has been developed on multilingual or mixed language query responses by Song et al. This study investigated language patterns such as language availability, morphology, and language family. Based on their experiments, this study included the following languages. Based on this list, Filipino was already included in their study. For the evaluation, they computed the bypass rate, which measures the percentage of unsafe responses with response to all LLM-generated responses. As a result, one of the languages with the highest bypass rate was Filipino, a low research language. So this is the presentation of the results of their study, which showed that Filipino, which is a low resource language, got a bypass rate of 5.83 from GPT 4.0. As such, the research problem states that most of the safety models focuses on languages with extensive resources. As such, developing safety models for low resource language is an active area of research. We aim to minimize the conceptual gap, data scarcity, as well as the bilinguality of the language. For the methodology, this is the graphical representation. I will go into step by step using the presentation. So for the data collection, the study started with the data collection. The experiment started with selecting an English language dataset from Hugging Face, like AI job prompts, XSS dataset, awesome chat GPT prompts, safeguard, and so on. So we introduced 15,433 safe and unsafe prompts. Additionally, a handcrafted dataset of short, unsafe prompts were created manually. There was a total of 8,561 prompts classified as safe and 6,872 unsafe. The classifications were manually verified and based on the existing dataset mentioned. The dataset was split into training, testing, and validation with a 70-20-10 ratio. Stratification was performed to ensure that the ratio of safe prompts to unsafe prompts remained consistent between the different sets. For the language, the data was translated into the Filipino language and was randomly categorized into hate speech, discrimination, suicide, and self-harm. Initially, the data was labeled 1 for safe and 0 for unsafe. The research utilized transformer pipelines, and the pre-processed input data was processed through the model. So we utilized the following transformer pipelines, namely CLM BERT base, XLM Roberta, and multilingual BERT. The tokens, which are the output of the mentioned transformer models, was input in the fully connected linear layer and a sigmoid function. So two linear layers to the output will be added to perform binary classification. The first layer is a fully connected dense layer with value activation function, and the second layer is designed to produce a single output unit followed by a sigmoid function. The output includes a safety score, which represents the degree of safety. It ranges from 0 to 1. Unsafe prompts were immediately flagged and blocked, ensuring that harmful interactions are avoided and the process remains ethical. Safe prompts, in contrast, are forwarded to the large language model, where they are carefully processed to generate a thoughtful and contextually relevant response for the user. Finally, a sample prompt not in the dataset will be plugged into the system, and the output will be delivered back to the user as the model response. The output is a two-element array containing the probability of the given input if it is safe or unsafe. The performance of the prompt safety classifier is evaluated using the accuracy, precision, recall, and F1 metrics. For the evaluation, to evaluate the prompt safety classifier's performance in an actual scenario, the prompts in the test set were fed as input into an LLM. The LLM's responses were evaluated as safe or unsafe. This was performed by assessing whether the LLM accepted or rejected the prompt. Rejection was determined using a rule-based approach defined by the presence of phrases such as hindi ko magagawa or I cannot perform in English or paumanhin or apologies in English. The evaluation of the framework was used attack success rate metric. The lower the ASR scores indicate a higher ability to reject unsafe prompts. The formula for the attack success rate is the total number of successful attacks over the total number of test cases multiplied by 100. For the testing and evaluation, the classifiers were uniformly trained under the same conditions. The models were trained for 5 epochs with batch size of 8 using the Adam optimizer and a decaying learning rate starting at 3e raised to negative 5. After training and tuning the BERT-based multilingual unpaced model, it was evaluated on the dataset test split containing 1,528 unique prompts. To better test the model's generalization, the test split was split into 2 and assessed afterward. Afterwards, its microaverage was calculated to determine its overall performance between the two splits. This is the performance of the three transformer models. given the data which is in Filipino. And then we interfaced the transformer models with two LLMs to differentiate the performance of the LLM without the additional layer of protection and with the additional layer of protection. So for Llama and Mistral LLM, the ASR got 29.36%. But with the additional layer of protection, which is field shield, the Llama 3.370B got an ASR of 0.73%. For MBERT and XLM Roberta, it got an ASR of 0.44%. And for Mixtral, 0.29%. As we can see, the attack success rate was lowered using the field shield configuration. For the conclusions, the range of 95% to 96% performance of the field shield classifiers indicates that the prompt classifiers can effectively distinguish between safe and unsafe prompts. The introduction of field shield significantly reduces the ASR metric by adding an additional layer of safety to the LLM. For the recommendations, further improvement in implementing an adaptive refinement mechanism for the dataset and model evaluation. This may be through noise injection techniques that simulate real-world prompts and automated linguistic validation tools such as context-aware language models that are explicitly fine-tuned for Filipino or Tagalog. Future researchers may consider expanding the dataset and model to accommodate prompts written in various Filipino dialects and Taglish or a mixture of Filipino or Tagalog and English to generate diverse, realistic prompts to make the model more adaptable to how residents in the Philippines naturally and commonly communicate. Thank you for your attention. I am now open for questions.
Good morning, ma'am. This is very interesting topic which I heard right now. And I want to understand when you are creating a vector for your abusing words or some problematic words, how you are going to manage, like whether you are going to dump that as a prerequisite keywords and how you are going to evaluate, like because there may be some spelling or some synonyms may be used. So how you are going to identify?
Based on our experiment, we initially took or got pre-made data sets from safetyprompts.com. Therefore, they were assumed to be already free from spelling errors. However, what we needed to fine-tune was the customization of the data set because the data set was built using the English language and it did not yet incorporated prompts which are built for the Filipino language. Pre-processing techniques to the model in order to eliminate cases where there will be, or in the actual scene, there will be wrong grammars or spelling correction.
Okay, thank you.
Thank you.
Thank you, ma'am. We'll be proceeding with the next paper presenter for the session. I'd like to invite paper presenter Elias with the paper titled Improving DNA Sequence Classification Accuracy Using a Hybrid LSTM CNN Deep Learning Model. So if you're ready, then you may start with the presentation. So Elias,
Yes, morning. If you can just unshare so that I can share
Yeah,
from
sure,
my side. Good
sure.
morning.
Please go ahead.
Okay. Morning, Chair. Morning, colleagues from the researchers domain. So my name is Elias Tabane. So this morning I will be presenting the paper on the improvement of the DNA sequencing classification accuracy using the hybrid LSTM CNN deep learning model. So the paper was written by Elias Tabane, Dr. Mukandla, and Dr. Weng. So it's a collaboration between the three authors, whereby I'm just the student to these two professors. So the table of content is as follows. We'll start with the motivation, why is it important to do those particular classification on the DNA. Also, we'll look at what the gaps have been saying on the literature review. Then we can also look at the exploratory data analysis before the experiments can be carried on. And then also we'll have to draw a conclusion of the experiments which have been done in order to understand if there are some improvements on the classification or there are any recommendations going forward. So the motivation of this paper is to address the critical research gaps, also to have an impact on the real world issues, particularly in the DNA sequencing, and also to enhance innovation around that particular DNA sequencing. So the study identified a significant gap in the existing research, and also with the motivation, it aims to provide some new insight that contribute to the field of advancement. Also, it aims to solve the real world challenges, improving industry practices or use the experience. And furthermore, the study seeks to foster the innovation and pushes the boundaries of the current knowledge. So the problem statement, or what we can refer as a phenomenon behavior, is that there is a lack of data accuracy and consistency when dealing with DNA sequencing, particularly with the human genomics. So the empirical situation is that this particular phenomenon or the problem which is encountered, it falls within the smart health domain. Some they can refer it as a bioinformatics domain. So also the aim of this research paper was to seek to address the issues of DNA sequencing and classification using the deep learning approach. As you may realize that the world now is moving from the machine learning into the deep learning, and then also with the deep learning there are a lot of algorithms which are coming through, especially in this age of AI. So definitely we need to explore and take an advantage of that deep learning to see if we can increase on the classification of the accuracy. If maybe machine learning was giving us 70% accuracy, we can try to run more tests using the deep learning approach and see if we cannot have some enhanced classification based on those new emerging algorithms. So also the literature review, several studies have explored the integration of the machine learning compression algorithm for the DNA sequencing classification and analysis. One study proposed the k-nearest neighbor classification method, utilizing the compression rates from the algorithm like the Brutlist and the gzip to measure the sequential similarity. Also, another research developed an advanced machine learning predictor, the IMCCA, for the detecting DNA secondary structures, achieving the strong performance in identifying the I motif confirmation using the balanced random forest and the XGBoost models. In addition to that, also a number of classification models, including the random forest.
Hello, sir.
Yes,
Sorry to
yes.
disturb you, but your presentation is not like your slideshow is not working.
Okay, is it moving now?
Not yet, sir.
I'm on page
Can
3 as we speak. Let me do this.
You
Is
need
it
to
moving?
put it in slideshow mode.
It's in the full slide mode from my side.
it's
Let me do this.
sir, can you just press F5? Okay, you can reshare and press F5.
Okay, let me do this. Let me reshare the. Is it now visible?
Yes, it is visible. And now can you just press F5?
Is it also visible now?
Yeah, but it is not in slideshow mode.
It's very strange because I'm also pressing F5 from my side.
Okay.
Much better now?
Um, no,
Try
it's
to share the full screen because you are sharing the windows. So as a result, it got stuck.
Okay, let me see if I can.
or if you can just share the PPT in chat, then I'll present from my end.
Okay, let me try again and see
Yeah.
if it can work. Is it much better now?
Yeah, it's good. It's good, sir. You can continue.
Okay, so I will just continue from the phenomenon behavior, which is the problem statement that there is a lack of data accuracy and consistency when we're dealing with the DNA sequencing for human genomics. So also the empirical situation that is that this particular phenomenon, this particular problem resides within the smart health domain. Some they call it the bioinformatics domain. So also the aim and the objective of this research paper seeks to address the issues of DNA sequencing and the classification using the deep learning approaches. So also we did a number of literature review trying to identify more gaps, especially moving from machine learning into the deep learning. So a number of those particular review was conducted. So one study proposed that the K nearest neighbor classification method utilizing the compression rates from algorithm like the Broadly and the gzip to measure the sequence similarity, which also demonstrated the high accuracy in classification of the DNA sequencing. And another research developed an advanced machine learning predictor, the IM-seeker, for the detecting of the DNA secondary structures, achieving a strong performance in identifying the I motif confirmation using the balanced random forest and the XG post model. So this particular machine learning techniques has also been reviewed for their application in genome assembling and gene annotation and variant calling, and highlighting their role in improving efficiency and accuracy in the genomic research. So in the overall, all these studies underscore the transformative impact of the machine learning in the biomedics, also paving a new way for the new discovery to personalize medicine and the genetic research. So also within the identify research gap, there was a challenge of interpretability challenge and also the data limitation and the generalizability issue. So the deep learning models in the genomic achieve the high accuracy, but also there is a lack of transparency, which make it more difficult to understand the prediction, limiting the clinical adoptions. Also with the data limitation, the training deep learning models requires some large and high quality labeled data set, which are often difficult to obtain due to the noise or what we call it data imbalances and incompleteness of the genomic data. So the generability issue, the deep learning model shows the promising in specific genomic task, but requires further research to ensure that they generalize effectively across the different species and the different data sets. For instance, we can do the DNA genome on the human versus the chimpanzee versus some other animals like your dog. So for instance, if you find some bones in the forest and you want to identify which class does they belong to humans, to animals, then we can do that particular genome using the latest algorithm from the deep learning models. So when we look at the exploratory data analysis, the data comes from the open source, that is the Kaggle, and then it was also the open domain. That means also the ethical clearance was obtained. So what we did normally, or what we do normally with the exploratory data analysis, which is the first step towards doing some evaluation or to run the particular algorithm, is to check for the missing value, check for the data distribution and the data imbalances. Also, we check for the noise, or some they refer it as outliers. And then also we can use the hyperparameters to tune our model. So when we check for missing values, we identify and handle any null and void or missing values in the data set to ensure that the data completeness and prevent errors in the model training, which sometimes leads to overfitting or underfitting. So also we check for the data distribution, whereby we analyze how the data is distributed, whether the classes are in balance, which can affect the model performance and also raises the issues of the biasness within that particular data set. Also, we check for the noise, the outliers, whereby we detect and manage outliers in the data set that could distort the patterns and negatively impact the model accuracy. So when you look at the distribution here of our data set using this pie chart, this particular data set is divided into 5 categories. We have the synthesis, and we have the ion channel, the G protein, the tyrosine phosphate, and the tyrosine kinase. So all of this, if you can look at how the distribution goes, the 4 of them have the 16.7%, whereas the synthesis it's still sitting at 33.3%. So this suggests that the synthesis protein are more dominant in the data set compared to other classes, which are equally distributed, but it doesn't mean that there is some imbalance. It also gives us an insight of our data that when we start to train and then start to look at the results, we know that synthesis was more in terms of percentage versus some other attributes. So with the experiment, what we did using the Python, what you call machine learning platform, is that the data acquisition was done and the pre-processing was done. Then we trained the test and split of our data set into the 80-20 ratio for the model evaluation. We also use the one-hot encoding for the DNA sequencing that are transformed into one encoded format, mapping each base into the 4-element binary vector. And then also we did the data reshaping, whereby the encoded sequences are flattened into the one-dimensional array to be compatible with the traditional machine learning and deep learning models. So also what we did, we trained our model using the classical machine learning algorithm, which is your logistic regression, the naive Bayes, the random forest, the k-nearest neighbor, and the XG booster, which we train and evaluate using the accuracy score. So the model evaluation, each classical model performance is printed as an accuracy percentage, allowing for more comparison. So the deep learning model, which was our proposed model versus this classical, or we normally call them the base model, is that the LSTM plus CNN, which is the hybrid deep learning model, combine the one-dimensional convolutional neural network bidirectional LSTM layer, and the dense layer is built to classify the DNA sequencing. So the final result after the training, the deep learning model, is an accuracy which is added to others, and also the model accuracy are displayed in the summary. So all of this summary is what transpired in our Python when we were doing the experiment. So like I said, we had close to 5 base machine learning models versus our proposed model. So if you look at how the performance went, is that the LSTM CNN model outsmart or outperformed the 5 base machine learning model, whereby the X-Boost was sitting at 81.5%, and then the LSTM plus CNN produced the 100% accuracy, and then also the overfitting and underfitting was taken care of. And then also we used the Adam optimizer to make it a point that we don't have the overfitting on our models as well. So in conclusion, this paper explores the deep learning for human DNA sequencing classification and determine the best combination of the features, architecture, and the hyperparameters to enhance the performance. So the hybrid LSTM-CNN model was found to be better than the traditional machine learning models like logistic regression the random forest, the accuracy by employing the LSTM for a long-range dependency, sorry about that, and the CNN for local pattern detection. So the study centers on the effectiveness of the deep learning in extracting the complex genomic patterns and highlights the importance of the pre-processing techniques like the one-hot encoding DNA embedded. And it also validates that the hybrid models are more effective than the standalone models like the CNN and LSTM. So the overall perception of the model of the paper is that it confirmed that the potential of deep learning in a DNA sequencing classification and open up avenues for the advancement in the genomics. So also this is just an ongoing research whereby I've also went and looked at some other models like your transformer models, the BET DNA, and some other transformer XL, and then also tested those particular models to see how their accuracy performance goes. And then also we can look at other deep learning models like your DeepSea, deep variant models as a way forward of exploring the entire deep learning model, so that we cannot say that LSTM plus CNN is the best model out of this. But also through the years, when more papers are coming in, you see more researchers are using the advanced deep learning models or the emerging deep learning models. So we also put those on test and see how they perform. And then also we'll make a follow-up paper whereby we compare this LSTM and CNN models with other models and see how it performs when we compare them to those transformer models and some other deep learning models. So also here are my references from the paper. It's also within the paper which will be also published. And I thank you for the attentiveness of the presentation. If there's any question, I'm willing to tackle those particular questions from the floor. Thank you.
This was really very interesting thing I observed, and really great work. Can I understand what is the meaning, why you have focused on one hot encoding technique over here?
Yes, so the one and hot coding technique, particularly with the DNA sequencing, it's important to transform that particular data set because it's something which is not understandable by the humans. So when we're using the one hot coding encoding, we make that data set to be readable on the CSF file, or you can call it when we're using the Excel file to run it on to upload it on the Python. So whenever we run it on Python must understand that particular data set as it is from the CSV file.
But there are so many other encoding techniques are available. Why specifically one hot?
One hot because when I look at some of the project which was done on the Kaggle and some GitHub, most of the researchers were using the one hot coded. So my assumption was that this must be the best practices. Hence, we adopt this as our best practice model. But if there's any other, I'm also willing to have a look at them on how they can enhance our models.
Okay, thank you.
Thanks, it's a pleasure.
Thank you, sir. We'll be proceeding with the next paper presenter. I'd like to invite paper presenter Kirtiraj Singh with their paper titled Industrial Fire Safety with YOLO V7, Overcoming Conventional Detection Limitations Through Advanced Image Processing. Sir, if you're ready, then you may go ahead.
Yes. Am I audible?
Yes, sir, you're audible.
Yeah, I can share my screen. Okay, is screen visible?
Yes, sir, it is visible. Please go ahead.
1 minute. Okay, so good morning, everyone. My name is Kirtiraj Sijala, and I'll be presenting our research work on industrial fire safety with YOLO 7, overcoming conventional detection limitation through advanced image processing. And this work was a collaborative effort by my colleagues Deep Dharmil, Hemant, and Jivesh Poddar. This is my presentation outline regarding the presentation, where we'll discuss the limitation of traditional detection system, and then I'll introduce YOLO 7 and explain why it is such powerful tool for this application. We'll also go through the proposed detection system and talk about how we prepared our data set and discuss the special adaptation we made for industrial environment. Uh, so research background, first slide. Industrial setting face the significant fire risk due to the, you can say, combination of hazardous condition. So this environment often include the combustible material, then complex machinery and high temperature. But traditional detection systems struggle in this environment for several reasons. First is they tend to have a high false rate alarm due to environmental interference. Second, they often unable to detect the invisible fire, and which can be just dangerous as visible one. Recent advance in, you can say, computer vision and deep learning, particularly with YOLO models, they have created a new opportunity for more accurate and reliable detection in this challenging setting. So as you can see in the figure, the invisible fire with smoke. A problem statement. Existing fire and smoke detection method in industrial setting face several significant challenges, like environmental complexities are major issue. Things like lightning condition, dust, machinery interference can confuse the traditional system. So another critical problem is the inability to detect the invisible fire, which might produce the visible flame or smoke high false rate alarm. That is the issue, causing the unnecessary interruption and reducing, you can say, trust in a detection system. So limited real-time detection capabilities are the one other also a problem. Our research actually specifically addresses the gaps by developing a robust real-time detection system using YOLO 7, and this system will design to detect the both visible as well as invisible fire in complex industrial environment. We'll be discussing. So this is my literature review. Basically, fire detection faces the several well-documented challenges. Environmental complexity makes consistent detection difficult. So traditional systems suffer from, again, I already we discussed that it suffers from high false rate alarm detecting and unable to detect the invisible fire. So now there are advanced deep learning approaches and models like CNN, YOLO 7 represent an important advancement in this progression. And it offers also several key advantages, like including real-time processing capabilities, higher accuracy than previous version, and improve the speed and detection capabilities, make particularly suitable for industrial fire detection. So this is our proposed model, where our data set came from RoboFlow and contains over 11,000 plus images across three critical categories like fire, smoke, and invisible fire. So for pre-processing, we resize all the images to standard 640 by 640 pixel to ensure the consistency. And we also normalize the pixel values to bring them within the consistent range. And to increase the diversity of our training data and help the model better, we apply several data augmentation technique, including rotation, flipping of image, color jittering, and everything. So that is my thing. Now, industrial adaptation. To make our system work effectively in industrial environment, we had to address several unique challenges, like particularly air can, you can say, air can interface with the detection. So we implemented the enhanced feature extraction layers to better handle the interference. Also, multiple heat sources are also common in industrial settings. So we have developed a noise removal technique to distinguish between actual fire and other heat sources. Same way, lightning variation are also another significant challenge. So we trained our model to be robust across different lightning condition also. main thing is invisible fire detection. So basically, in the invisible fires represent particularly a dangerous challenges in industrial setting. This fire might not produce the visible fire flames and can result from you can say chemical reaction or electrical malfunction. So our approach to detect these hidden threats like invisible fire includes several specialized strategies. We incorporated a specialized data set focusing on specifically these hard detect cases, and we also integrated thermal image analysis to identify heat signature that might not be visible to be naked eye or traditional camera. And also we are developing a detection algorithm that identify the indicators of combustion otherwise go unnoticed. This is our experimental setup. So our performance matrix has an impressive matrix, that is we reached the precision of 90%. Yeah, we reach the precision of 90%, meaning that when our system detected a fire, it was correct 90% of the time, and our recall was 84%, indicating that we successfully identify 80%, 84% of actual fire instance in our test set. Mean average precision we got 0.5, as well as we actually got the processing speed of 30 fps. Same way, our training parameters, we use the batch size of 16 and train the data set up to 80 epochs. And our hardware, you can say, where we have implemented is NVIDIA Tesla V 100 GPU, that is Param Shavak, given by government of India to different university. Uh, Same way, yes. So conclusion of our research is to detect you can say invisible fire. Same way, our system also achieves high accuracy with minimal file false alarm, operate in real time, and effectively identifies both visible as well as invisible fire. These capabilities also includes the critical gap identified in traditional detection system. And our future work will focus on several key areas like you can say additional industrial environment beyond we have tested so far. Same way, we are also exploring the incorporation of multi-spatial vision to future enhance the detection capability, or also we are working on increase the system capacity to handle even broader application across the different sector. So these are our conclusion. These are the reference I have used in my published paper in ICTIS 25, and I'm happy to answer your question regarding my paper. Thank you.
I'm very happy to see such a nice thought process. Uh, what if we are going to try what we are means what if we are trying to add some more complicated AI system to it? Have you given a thought process for the same?
Right now, actually, we are only first, whenever we have selected a problem, our main focus was actually detection of invisible fire. Basically we are searching that what kind of models we can use. So then we come to conclusion that YOLO 7 is one which we can use. But again, right now the YOLO versions are up to YOLO 11. So might be possible that we will be in a future work we'll be using the certain AI application with the incorporating the latest YOLO version, which gives the more accuracy and give the more benefits.
Is the YOLO version is chargeable or means how it is? It is a free open source?
Yeah, it is a open source. It is a one kind of framework, or you can say tool, and it is a free of cost.
Okay,
Yeah.
thank you.
Okay, thank you.
Thank you, sir. Thank you, ma'am. We'll be proceeding with the next paper presenter. I'd like to invite paper presenter Suyash Kolte with the paper title Lane Guard, an AI-powered real-time monitoring system for cycle lane violation detection. So if you're ready, then you may start with your paper presentation. Sir Suyash? It seems we do not have him in the meeting. We'll be moving on to the next paper presentation while we wait for him. Paper presenter, Sarat Mehta, with the paper titled Real-Time Anomaly Detection in Smart Energy Systems Using Statistical and Adaptive Learning Techniques. So if you're ready, then you may go ahead.
Okay, maybe you can
Yeah,
take off your screen here.
yeah. Please go ahead.
Hope I am visible.
Yes, sir. Please go ahead.
Okay, so myself, Sarit Maitra, we have written this paper along with my fellow colleagues, Mr. Kapil Arora and Ms. Sukanya Kundu. We are affiliated with Alliance University in Bangalore, in southern part of India. This paper is about real-time anomaly detections in energy systems, smart meters. Here we have developed a statistical model. I will explain why statistical model in the age of AI/ML. But just to give a background, rapid growth of industrial and commercial sector is driving a significant increase in energy and consumption worldwide. So in order to curb that, understand the anomalies in the energy consumption, we have to come up with some real-time anomaly detection system. So there is a need and there is a gap. The gap is most of the paper in the recent times, what we have studied are focusing on AI and ML. But those are at the research phase, and the paper is getting published, but there is no real-time deployment. So, so we understand where is the gap and how to address that gap. Then we came up with this model. The challenges with real-time anomaly detections with AI ML, because AI ML require massive amount of labeled data. So the heavy reliance on the large and labeled data sets, which is often scarce, because most of these data collected in the energy consumption using smart meter is the sensor data, which has no label. And on the top of that, some unsupervised model can address the unlabeled data, but unsupervised model are not easy to predict or interfere or inference. So the inferential issues becomes a complex matter, when it comes to the deployment of the model. So more on the top of that, the high computational requirement, which makes the real-time detection extremely difficult. So lack of interpretability, high computational cost, sensitivity to normal trends, seasonal variations, reliance on large labeled data, all these things are hindering the applications of AI and ML in energy anomaly detections. So need is a lightweight, interpretable, scalable, and adaptable. The last line of the slide. That's what we require, where we deployed statistical model, which is a hybrid model of three different statistical popular framework. So the problem is again, dynamic energy usage pattern. Several authors in the past have conducted anomaly detections using smart meter data. While ML, as I already discussed, ML is a powerful tool, but it has its limitations. So we propose a three-step approach combining EWMA, which is exponentially weighted moving average, quantile regression, and adaptive windowing systems. Problem is that there is a real-time detection system is required. There are several ML algorithm is been developed, is been tested, empirically tested, but nothing is at the deployment stage. To address that problem, we came up with this model. Now, of course, this leads to sustainability and cost concerns in the real-time detections. So before we go to the methodology, the data preparations in this, the data is collected from Schneider Electric, they published the data from 2012 to 2016. So we collected the data, and the data has a lot of preparation, pre-processing stage, where a lot of missing values and the data distributions, all these things have been taken care, and which took almost 50 to 60% of our effort in the data analysis phase. So the key challenges here is the usage pattern we have found is that usage pattern is changing dynamically over time. So the data obtained from the factory monitoring systems, anomalies could be for various reasons, could be due to equipment failure, due to changes in the production process, or the external factors. So there is a potential cause of concept drift in here. So thus, thereby, we incorporated the adaptive windowing function, which is a concept drift detections. So let's discuss about these three framework we have used. One is EWMA, which is exponentially weighted moving average. Why exponentially weighted moving average? Because it puts weight on the recent past. Then quantile regression for adjusting the seasonal variations, and then the adaptive windowing process. And we have used rolling quantiles for the find out the threshold, dynamic thresholds. In the following slides, I'll take some time to explain these slides, the framework, mathematical framework of these. So this size is, if we take at the first one, let me take my pen. This EWMA, this equation. So this equation is again, it's a exponentially moving average. It smooths out the short-term fluctuations. Here, the baseline threshold is T. This T, and then it is EWMA. It is taking on the past value, weighted on the past value. So baseline threshold at time T is a weighted average of the current observation and the previous baseline. Here, alpha is the threshold, or alpha, we can call it alpha is a smoothing factor. So this is about the EWMA. Then we come up to the quantile regression. Quantile regression is, it's a simple regression equations where beta is the regression coefficient, and these are the, there is the seasonal variations depending on the hour of the day. H is the hour, D is the day, and then the last one is M is the month, and then of course there is an error. So our day and month, which is capturing the seasonal pattern of the energy consumptions. And then the adjoint detection here we come is the probability of it detects and adapts changes in the energy consumption pattern. It's kind of concept drift. So it's the probability that absolute difference between the estimated mean and this is the estimated mean and the true mean, and which is greater than the absolute error. So if I can explain that a little bit more in simpler terms, it is the chance that our estimate of the average is off by more than a certain amount. The second part of the equation, this part, so this part is the upper bound on that probability. This part states that the probability is less than or equal to a value determined by the exponential expression. So this is n is the number of data point, This is the error, and E is the Euler function. Euler function is 2.718. We all know that. Then finally, the anomaly is flagged, is the T final T. The final T is this one is the final T. Final T is combining of all three framework together, including the thresholds. So the threshold is, multiple thresholds are used here, used over here. The thresholds are very, very important. Thresholds are, first is EWMA based smoothing threshold. So before anomaly detections, it applies, it filters out the short-term fluctuations. Second is the quantile regressions is a seasonal adjustment. It adjusts for the seasonal trends. This is also before the anomaly detections. Then the drift detections, which is the adaptive windowing systems, which detects the long-term shifts, which is during the monitoring. Then finally, the adaptive thresholds, which determines actual anomalies. So this is the time-weighted moving percentiles. Now, here, if you see the plot, the distribution plot, in the distribution plot, we have plotted, which is the red line right above the red line is the anomaly detections. So to identify the anomalies, we analyze the distribution of anomaly scores and establish the threshold. This threshold is set at 95th percentile, ensuring the top 5% of the outlier or the anomalies are most unusual data points, which is, of course, so by the framework which is flagged as anomalies. In this current data, we found 373 anomalies observed applying this framework. This threshold is around 4.92% of the data, which is above the 95 percentile of this data. That score, anomaly score, we have obtained. If you look at this formula, if you all look at this formula is we have detected the anomaly score using this formula. Here, if you see, each component is assigned with a weight. This weight is balancing their contribution to the final. So each component here, there is a weight on EWMA, there is a weight on quantile regression, there is a weight here also on G score, and there is a weight here also on the drift. EWMA residuals, this residual part captures the deviation from the rolling baseline threshold. This is indicating the short-term anomalies. That's what the weighted moving average principle.
Excuse me, sir. I'm really sorry to disturb you, but I'd like to remind you of the time limit.
Okay, I'll go quickly.
Yeah, sure.
Okay, so these are the thresholds. And if you look at the table below, the table has all the parameters we have used. If you see if you can ask questions like why 30% is taken for some of those variables. So the 30% are equal weightage given to all the variables. So that's the objective. But for another kind of anomaly detection, this parameter can be adjusted. Now, practical implications, we have compared these with machine learning and deep learning based model with our approach. This is what is our approach. And we found all the positives and also moreover that we don't need any training data as because it's a statistical model giving preference to the descent weightage. So conclusion is this is a hybrid depth approach, improves the robustness. This is a real-time processing, and this has got the statistical threshold, which is ensuring the interpretability and adaptability. Requirement is finally the model has to be deployed. Model is tested, but has not been deployed yet. So we are taking this model to Snyder. We approach them to deploy this, but which has not been done yet. So that's the end of it. If there is any questions, I can take it, please.
This topic was really nicely explained. I think you were pretty into it, and that's why you were trying to give us more knowledge on it. You mentioned about threshold in your case, and I was trying to understand how you set the threshold value.
threshold is there are different framework, right? Different framework is used. Every framework we need the dynamic threshold. In the sense, we are taking the data from the recent past and then find out what happened in the recent past and then find out the future if there is a probability of coming up with anomaly. Now, what if the data distribution changes? If we use a fixed threshold, if the data distribution changes, then that fixed threshold would not be able to determine what is the future anomaly points. So that's why we have kept the threshold in such a way it changes dynamically along with the distribution of the data. Does that answer your question, ma'am?
Yeah, but how it was affecting in your research? That was my concern.
So if I go back to here, you see this slide, if you can see the distribution pattern, this distribution pattern here, I have mentioned also the threshold. This threshold is dynamically adjusted. If the data distribution is changed, this will be adjusted dynamically. Considering the current data, this is around 4.92% of the data is anomalies. If the
Why
data,
dynamically?
sorry?
Why dynamically? Why there is no policy defined for adjusting this threshold?
Policy is the dynamic based on the data distribution. That's the policy. The threshold has to be adjusted.
There should be some rules and regulations to define or to adjust this threshold value. No? That's what is my question.
If you define, then that's not a data driven. If it is data driven, it has to be dynamic.
Okay, you just think, give a more thought on it.
Okay.
Thank you.
Thank you.
Thank you, sir. I'll be proceeding with the next paper presenter. I'd like to invite paper presenter Kajal with the paper titled Smart Shelf Life Monitoring System for Real-Time Shelf Life Assessment and User Feedback Integration using Raspberry Pi and 80 Mega 256 RF-R2 sensors. Ma'am, if you're ready, then you may go ahead.
Yes, I'm ready. Good morning, everyone. My name is Kajal Salampuria, and today I'm going to present on Smart Shelf Life Monitoring System. It is a real-time shelf life assessment and user feedback integrating using Raspberry Pi 80 Mega 256 RFR-R2 sensors. So globally, about 1.3 billion tons of food wastage per year each year has been seen. It is roughly 1/3 of the food produced globally. A major reason behind this inefficient manual shelf life tracking. A solution is the sensor-based system that can assess shelf life in a real time using Raspberry Pi 80 Mega 256 RFR2 monocontrollers. It is combined with a mobile app for a user, which can interact and give the alerts as well. These approaches can help to reduce the wastage, and it can improve the inventory management as well. Our objective is to develop the real-time shelf life monitoring system, integrating user feedbacks to improve the accuracy, optimizing system for large-scale implementation. So while developing the real shelf life monitoring system, it can help to reduce the food wastage. And we are also taking the feedbacks from the users, and which can also help to improve the accuracy of our application and our sensors as well. It can also help in optimizing the large scale implementation. So this is the research methodology. The sensors are collaborating with each other. Um, 80 mega 256 RFR2 sensor, uh, which is collaborating with Raspberry Pi. It can help to ensure the accurate reading of the shelf. Uh, this sensor can also collect the data such as temperature, humidity, and ethylene gas level, and can help in transmit it to Raspberry Pi. This machine learning algorithm on the PI then analyze this data to estimate the shelf life. This can also result uh, in integrating with cloud services for the real-time monitoring and the analytics as well. This is the algorithm. The first step is installing the sensors on the shelves, monitoring the temperature, humidity, and ethylene gas levels. Uh, third step is transmit data wirelessly to the Raspberry Pi. Predicting the shelf life using algorithms, sending alerts on mobile application for expiry warning for the perishable goods. It can also get the feed. The last but not the least, the step is user feedback integration, which can provide us the accuracy. The user can provide their feedback, which can help the system to learn more and improve the quality over the time. These are some applications of our sensors. It can be used in retail shops, supermarkets as well. It can also used in warehouses for storing the perishable goods. It can also used in restaurants. Can be also used in e-commerce. Home. It can also use in home as well. It can also be used in food industries. So this is the conclusion: innovative system using Raspberry Pi and 80 mega to 56 RFR2 sensors. It is a real-time monitoring which can reduce the food wastage and improve the efficiency. The mobile application integrates, provide instant access and alerts, which can help the particular person who is using the sensor to reduce the wastage of food material, and it can be used to give to those who is needed with the food. And it is a continuous improvement can be also seen using the feedbacks of the users. So that's all for from my side. You can ask me the questions.
This was very sweet presentation, short
Thank
and sweet.
you.
I want to understand, have you implemented this? You have made a working model of this?
No, I didn't make a working model because I am a student of commerce and management. So I didn't work on implementing this. But after seeing the food wastage, I have got the idea to do this. So if I get some engineers, then I can do this.
Yeah, definitely we can give you an engineers. But yeah, the thing is like sometime proposing idea and the implementations are two different things. But really
Right.
a good thing, highly appreciated besides from different domains. So
So much.
good. Okay.
Thank you.
Ma'am Kopaka with the paper titled Transfer Learning Enhancement. Enhance scalable convolutional neural networks with multi-layer feature optimization for predicting periodontal disease using dental X-ray imaging. Ma'am, if you're ready, then you may go ahead.
Yes, ma'am. I'm ready.
Yeah.
Is my screen visible? morning, everyone. I'm Kopaka Sri Samhita from Traditional Engineering College for Women, Bhimavaram, India. I'm happy to present our project title Transfer Learning Enhanced Scalable Convolution Neural Networks with Multi-Layer Feature Optimization for Predicting Periodontal Disease using Dental X-ray Imaging. This is a part of our final year BTech work under the guidance of Mr. Yugandhar sir. My teammates are Kanna Sailakshita, Srujana, Swati Chaudhary, and Selina Anand. Our paper focuses on how AI, especially deep learning, can be used in the field of dental health to support fast and early diagnosis using X-ray images. Coming to the abstract of our project, periodontal disease, which affects the gums and bones supporting the teeth, is very common but usually gets ignored in the early stages. If not treated, it can lead to tooth loss and other health issues. Dentists often use dental x-rays to detect it, but interpreting them can take time and expertise. In our project, we used a deep learning model with transfer learning. That means we use a model already trained on large image datasets and adapted to work with dental images. We also applied a multi-layer feature fusion technique to improve how the model understands and learn patterns from the X-rays. Our result shows that the model performs with high accuracy and can help dentists in clinical settings. Coming to the introduction, to give a background, periodontal disease is one of the most widespread dental problems. It is usually silent and painless in early stages, which is why many people don't know they have it. Dentists use clinical tools and x-rays to detect it. But the process can be subjective, slow, and depends heavily on the dentist's experience. That's where artificial intelligence can help. Deep learning models, especially CNNs, are great at analyzing images and spotting patterns. But basic CNNs sometimes don't work well with the dental images due to a low contrast and overlapping structures. Our idea was to improve these models by adding transfer learning and combining features with from multiple layers to improve detection accuracy. Coming to the objectives, our project has several key goals. First, we wanted to create a system that can automatically classify X-ray images into healthy and diseased categories. Next, we aim to increase the overall accuracy of detection compared to manual diagnosis or traditional CNN models. And we also wanted the system to be able to identify different stages of disease such as gingivitis or periodontitis. Another important goal was to reduce the time taken by dentists for diagnosis and assess them with quick and reliable support. Lastly, we wanted our model to be scalable so that it can be used on different kinds of X-ray images and integrated into clinic software or even mobile apps in the future. Currently, periodontal disease is diagnosed by dentists based on visual inspection of X-rays and clinical signs like bleeding or swelling. This manual process takes time and vary from one expert to another. In rural areas or busy clinics, it's not always possible to do a detailed analysis for every patient. Also, some signs of disease may not be visible until the condition gets worse. There's also a lack of automated tools that are trained specially for dental images. So our idea was to bring in deep learning to help automate this process, reduce errors, and speed up diagnosis, especially in areas with limited dental professionals. Coming to the proposed methodology, currently periodontal disease is diagnosed by dentists based on visual inspection of X-rays and clinical signs like bleeding or swelling. Our method brings with data pre-processing where we resize the X-ray images to 224 into 224 pixels and convert them to grayscale. We also apply augmentation techniques like rotation, flipping, and brightness adjustment to make the model robust. And then we use a pre-trained MobileNet V2 model for feature extraction. MobileNet V2 is lightweight and works well for image tasks. On top of it, we added fully connected dense layer for classifying the images. During training, we used Adam optimizer and binary cross entropy as our loss function. We also applied a learning rate scheduler to improve training efficiency. Once the model is trained, we evaluate it using various metrics and prepare it for real-time deployment. Coming to the dataset description, we used a collection of dental x-rays that include different types like periapical, bilateral, and paranomic. These images cover various stages of periodontal disease and are labeled accordingly. We divided the images into two main classes, that is a class 0 for healthy and class 1 for diseased. To make the model more general and avoid overfitting, we performed data augmentation and normalization. The dataset was split into training, validation, and testing sets. This helped us evaluate how well the model performs on unseen data. The use of different types of X-rays makes our model more flexible for real-world use. Coming to the results, we can see that the MobileNet V2 performs well among all the models like a VGG, CNN1, and CNN2. Our model showed a very high performance during evaluation. We achieved an accuracy of 98.61%, which means the model correctly classified most of the images, and the precision was 98.66%, showing that it rarely gives false positives, and the recall was 98.63%, meaning it correctly identifies the diseased cases, and the F1 score of 98.60% gives a balance between precision and recall. These results are better than traditional CNN models and show that our approach with transfer learning and feature fusion has improved the model's ability to understand dental x-rays. The system is also fast, which is important for real-time clinical use. Coming to the future scope, our current model is working well, but we have plans to improve it further. First, we want to deploy it in actual dental clinics and observe how it performs in real time with live patient data. The second one, we want to increase the size and diversity of the dataset by collecting X-rays from different sources. And the third, we aim to optimize the model for edge devices, which means it can run smoothly on mobile phones or tablets. This will make it useful even in remote or rural clinics where internet and hardware resources may be limited. To summarize, we have successfully built a deep learning model that uses transfer learning and multi-layer feature optimization to detect periodontal disease from dental x-rays. The model gives high accuracy, works faster than manual diagnosis, and reduces human error. It can be a great support system for dentists, especially for early detection and treatment planning. This approach not only helps in dental health care, but also be adapted for other medical imaging tasks where quick and accurate diagnosis is essential. These are the references for our project. Thank you all for your attention. It was a pleasure to share our with you today. I hope you found it useful and interesting. I'll now be happy to take any questions or feedback.
Yeah, very nice presentation on the topic called as a transfer learning, and that too in the health domain. What type of features you have considered with the predefined values for understanding the dental x-rays?
Can you please repeat the question again?
When you are applying the transfer learning concept, you have to follow some predefined values to check whether the values are as per the same methodology or not. And then based on that, you are upgrading the training session. So that is the main core behind the transfer learning. So because we have published 3 to 4 papers in the transfer learning, and I have given 8+ session on the transfer learning at different places in India. So that's why I want to understand that for the dental X-ray, what type of features you have rechecked?
Like in our project, we extract deep features from the X-ray images using a pre-trained MobileNet V2 model. These features include edges, textures, shapes, and patterns found in the gum and bone areas of the dental x-rays. At the lower layer,
Okay, so these are the features you have already got from the previous model or previous data set.
yes, it's already trained, and we also give our training data set to it so that it can learn more and perform well.
So have you validated that values, whether it is applicable or whether it is giving the correct answers for your new data set? Because you are using existing data set, right? Already trained data set, already trained feature.
Yeah, we tested with the new data set also. It gave approximately correct.
Okay, so yeah, okay, good. Thank you.
Okay, thank you.
Thank you, ma'am. We'll be proceeding with the next paper presenter. I'd like to invite paper presenter Vanessa with the paper titled Transforming Guest Experiences, the Role of Smart Technologies in Modern Hotels. Ma'am, if you're ready, then you may go ahead.
Yes, I'm ready.
Yeah, sure.
Good morning, everyone. We are from Bina Nusantara University. Today, me, Vanessa Putra Evelyn, and my team, Jesselyn Esilia, Grisanda, Yurida Lilianita, and Ikwan Masanadi, will explore about transforming guest experience, the role of smart technologies in modern hotels. Next slide. This is our table of contents. Next. Next slide. The hospitality industry is undergoing a digital transformation, leveraging AI, IoT, and automation to enhance efficiency and guest experience. Slide 2, please. Introduction. Okay, continue. These smart technologies enable personalized service, improving customer satisfaction and loyalty. However, challenges such as data security, privacy concern, and resistance to change must be addressed. When effectively implemented, this innovation contributes to operational efficiency and sustainable business growth. This research explores how smart technologies impact customer experience, loyalty, and long-term success in hospitality. Next slide. This is our literature review, Smart Technology in Hotel Business. Smart technology refers to advanced system utilizing AI, IoT, big data, and automation to enhance efficiency and customer experience. Guest experience includes all interaction a customer has with a hotel, from booking to post-stay services. Guest loyalty, the likelihood of guests continuing to use the same hotel services and recommending them to others. And last, business sustainability, balancing economic, social, and environmental aspects to ensure long-term success while minimizing negative impacts. Next slide. This slide outlines the study's hypothesis, focusing on how smart technology impacts guest experience and ultimately drives guest loyalty and business sustainability. The hypotheses are: Hypothesis 1, smart technology positively impact guest experience. Hypothesis 2, a positive guest experience enhances customer loyalty. Hypothesis 3, higher loyalty boosts business sustainability. And the last is hypothesis 4, smart technology also directly influences business sustainability. This framework emphasizes the role of technology in improving customer satisfaction and long-term business success. Next slide. The study follows a quantitative methodology focusing on numerical data analysis. The target population consists of customers from 5-star hotels, ensuring insight from a high-end hospitality segment. A purposive sampling technique was employed, selecting respondents based on specific criteria relevant to the research. Data was collected through a survey, allowing direct responses from participants, and analyzed using structural equation modeling, or simple S, to examine complex relationship between variables. The demographic result provide a clear understanding of the respondents. In terms of gender distribution, 53.8% were female, while 46.2% were male, indicating a fairly balanced representation. From the age distribution, show the most respondents were between 18 until 25 years old, as 37.6%, followed by 26 until 30 years old, 33.2%, with smaller percentages in older age groups. This suggests that younger adults make up the majority of luxury hotel customers surveyed. The occupational breakdown reveals the private employees and entrepreneurs were the dominant group, followed by the college student, influencer, and the students. This diverse respondent profile ensure a well-rounded perspective in the study. The combination of a structured research approach and detailed demographic insights allow for a comprehensive understanding of consumer behavior in luxury hotel settings. For the next slide, you have the result of hypothesis. This slide presents of the result of the hypothesis testing, confirming the significant relationship between key variables. The findings show that smart technology positively impacts guest experience as hypothesis 1 with a strong estimate of 0.780 and a highly significant t-value of 13.019. Additionally, guest experience enhances guest loyalty as hypothesis 2 with an estimate of 0.408, while the guest loyalty contributes to business sustainability as hypothesis 3 with an estimate of 0.491. Lastly, the smart technology also directly influences business sustainability as hypothesis 4 with a strong estimate of 0.730. All hypotheses were accepted as indicated by the p-values of 0.000, confirming the robustness of this relationship. These results highlight the importance of smart technology in improving guest experience, fostering loyalty, and ensuring long-term sustainability. Next slide. This is our result and discussion. First, hotels that integrate AI and I significantly improve guest satisfaction by offering seamless, personalized, and efficient services. Smart technologies such as AI chatbots, AI-powered smart rooms, and digital check-in improve efficiency and convenience of the guest. Second, a positive guest experience increases guest retention, encouraging repeat visits and stronger brand loyalty. Guests are more likely to return if they experience efficient, personalized, and hassle-free services. Third, retaining loyal customers ensure long-term revenue stability and reduces costs of acquiring new guests. Repeat customers provide consistent revenue and help reduce marketing costs compared to acquiring new guests. And last, automation and AI reduce operational costs, optimize resources, and enhance sustainability. Hotels using AI-based energy management and automated processes reduce operational costs and environmental impact. Well, these are the business implications, such as a hotel must invest in smart technology like AI chatbots, AI-enabled rooms, and mobile check-ins to enhance efficiency and guest engagement. Personalized services driven by AI and big data help with customer loyalty. Sustainability efforts such as AI-based energy management reduce costs and attract eco-conscious travelers, while the automation improves efficiency. Maintaining human interaction is essential. I should handle the routine task, allowing staff to focus on personalized guest experience. And then next slide. For the conclusion and limitation, first, smart technology enhances guest experience. Second, guest experience drives customer loyalty. Third, customer loyalty contributes to business sustainability. And last, smart technology directly supports business sustainability. And there are some for the limitation. First, the limited scope focusing on the 5 hotels in Jakarta. Second, the quantitative only approach. And the third is short-term impact analysis. Next slide. This is our recommendation for the future research. First, expand research to different hotel categories and location. The current study focuses only on 5-star hotel in Jakarta, which may not represent how mid-range budget hotel or hotels in neighboring countries implement smart technology. Future research should expand to various hotel categories and geographic location to provide a broader understanding of technology adoption in different hospitality markets. Second, incorporate a qualitative approach for deeper insight. Quantitative methods or as simple as modeling does not capture guest emotion, preference, or concern about smart technology. Future studies should include in-depth interview, focus group, or case studies to better understand how guests perceive AI-driven services and digital automation in hotels. And last, compare smart technology adoption in luxury versus budget hotels. Smart technology adoption may differ in between luxury hotel, mid-range hotel, and budget accommodation. Future research should compare how different hotel segments implement technology, assess guest expectation, and analyze whether affordability affects the level of AI and AI integration in the hotel's operation. Next slide. The study had to fulfill one of the requirements to graduate from Diploma Hotel Management at Bina Nusantara University, Indonesia. Therefore, the authors would like to thank Bina Nusantara University for its support on this study. Next slide. We would like to thank you for your time and attention. We truly appreciate the opportunity to share this insight with you. And we hope that this discussion has been valuable. If you have any question, we will be very happy. Thank you very much.
Thank you, ma'am. Ma'am Aarti, would you like to ask any question?
No, thank you.
Okay. So we'll be moving on with our next paper presenter. I'd like to invite paper presenter Shivangi Surati with the paper titled Western Disturbances, a comprehensive review of modeling approaches and research directions. Ma'am, if you're ready, then you may go ahead.
Yes. First of all, good morning, everyone. Myself, Dr. Shivangi Surti, and here I'm going to present a paper that is paper ID 454, Western Disturbances, a comprehensive review of modeling approaches and research directions. This work is in a joint collaboration with my co-authors, Khushi Shah. She was my student, and recently she has received her BTech degree, along with Dr. Bipasha Paul Shukla. She is from Indian Space Research Organization, ISRO, in Gujarat. For applying the modeling approaches, first we carried out the review of existing approaches, and that is what we are going to present here. So this is the outline of the presentation, beginning with the introduction. First, we will define the Western disturbances, that is also known as WDs. They are extratropical weather systems that originate over the Mediterranean, Caspian, and Black Seas. And they travel eastwards across Iran, Iraq, then Afghanistan, Pakistan, and finally they reach to India. So they normally appear in the winter months and from November to April month, and they are most frequent during January and February. So due to this, this is an interaction between the cold polar air and warm moist air, and they are responsible for the winter rainfall basically. So structurally, they consist of a low-level cyclonic circulation and an upper level through, and they are having jet. Their lifespan varies with short-lived systems lasting 2.5 to 3.5 days. Moderate ones, they are from 4 to 5.5 days, and longer ones, they persisting from 8 to 12.5 days. So they contributes to around 15% of the total rainfall in Northwest India, which is essential for sustaining the rabi crops. And it also leads to an expansion of Himalayan glaciers. So But in case of intense WDs, they can also lead to hailstorms, extreme weather anomalies, and natural disasters, such as avalanches, flood, and landslides. So, though they have their major role in regional climate dynamics, accurate prediction of WDs remains always a challenge, and their complex formation, movement, and interaction with large-scale atmospheric circulation patterns. So basically, we conducted this study to go through a comprehensive review of different modeling approaches used till days for WD forecasting. So we analyze their strength, limitation, and potential improvements to enhance forecasting accuracy. So the objectives of our work, the primary objective is to study and analyze as well as compare different modeling approaches for Western disturbances prediction. We assess both mesoscale and global climate models to understand their effectiveness in simulating WDs. Another key focus is also on identifying the challenges in existing models so that we can also propose a new model to carry out our work. So this includes biases, parameterization issues, and data assimilation limitations. So by addressing these gaps, it is also crucial for improving the forecasting accuracy. In addition, we also explore advancements in AI and machine learning, evaluating their potential to enhance WD prediction as our next research part, as integrating AI can lead to more precise and data-driven forecasting methods. Lastly, we also highlight research gaps and propose future directions for refining the WD modeling and their current impacts. So by tackling these objectives, our study basically aims to advance WD research and contributing to better forecasting and risk mitigation. So basic methodologies, we studied various extensive literature review from latest modeling techniques. We collected data from multiple scientific repositories, and our using Boolean search techniques also, we have studied the existing literature up to 2024. So we categorize the study based on modeling techniques, objectives, and resolution to identify the strengths, limitations, and gaps. So this is the comparative analysis of the similar existing reviews and how our review differs from that. So first of all, Dimri et al., they have focused on the historical undersampling, dynamics, and impacts of WDs. They mainly emphasize on topographics role. Next, Hunt et al., they analyze the seasonality and spatial variability of WDs, and they used reanalysis data and regional observations. And the most recent work, Hunt et al., they linked WD behavior to climate variability and anthropogenic factors using a multidisciplinary approach. So our paper basically focuses on the studies by synthesizing various modeling techniques. We have identified research gaps and highlighting the potential of integrating AI/ML algorithms for predictive modeling of WDs. So these are the various modeling techniques that we studied in our review work. So first of all, the WRF model, it provides the high spatial resolution and customizable physics schemes. However, it is also highly sensitive to parameterization schemes and is computationally intensive. So this can lead to inconsistencies when we perform the simulations, and also it is difficult to make the real-time forecasting using these models. Next, we studied the MM5 model, which improves cloud microphysics representation and large-scale circulations also. But again, it has a high computational cost, and it basically struggles with the complex cloud interactions, which may result in errors in extreme weather predictions. Third one, the REC-CM3 model that is useful for long-term climate studies and regional analysis. It struggles with extreme event simulation and depends on GCM inputs. It has its limited accuracy. Next, QPE model, it has high temporal resolution, and that's why it is valuable for real-time applications. However, it also suffers from errors. It has errors like instrument limitations, and snowfall estimation has less accuracy. Then CMIP5 model, it helps in climate change projections and ensemble-based analysis. However, it also has low spatial resolution and large biases in regional precipitation. Then ARPS model that is effectively captures the convection and mesoscale features. However, it requires detailed initial conditions and has high computational demands, making it impractical for operational forecasting in resource-limited settings. So this slide represents our overall comparative analysis. The last one is Arkin's rainfall estimation model that is useful for drought monitoring due to its long historical records. But again, it has limited accuracy for light rainfall and struggles with orographic effects. This can lead to underestimation of precipitation in mountain regions. So each of these models have their own limitations. And based on that, we have some key findings based on this review. So the key findings are threshold-based models such as Arkin's models. It struggles with fixed threshold values like cloud cover temperature. And this results in poor generalization across diverse WD events, and it leading to unreliable predictions also. Then mesoscale models, which includes PSU, NCR, and WRF, they face uncertainties due to initial conditions and parameterization schemes. Then orographic complexity effects models such as MM5, which underperform in rugged terrains like the Himalayas. So this again impacts on accuracy in predicting surface and atmospheric variables. That may lead to the errors in WD simulation also. Then bias in forecasting is common in models like RegCM3 and WRF, which tend to overestimate the rainfall or simulate overlay strong storms. So this systematic biases reduce the reliability on precipitation forecast. Last one, data-driven methods such as k-means clustering, it also struggles to distinguish WD-induced rainfall from other atmospheric phenomena. So based on these challenges, they highlight the need for advanced forecasting techniques to improve WD predictions and simulations. So these are the research directions that we would like to propose for the researchers and organizations working in this area. First of all, there is a requirement of high resolution modeling that enhances the ability to capture WD dynamics more accurately. This leads to better spatial and temporal precision in precipitation forecasts. Then next, improved parameterizations that will be improved in cloud microphysics, convection, and land atmospheric interactions. They help in reduce biases in models. So this refinement ensures more reliable simulations on WD behavior. Then next, there is also need of advanced data assimilation techniques that integrates the observational data like MODIS and WDR to improve the model initialization. This also enhances the accuracy of WD forecast by incorporating the real-time atmospheric conditions. Next, AI/ML integration also enables the better detection. We can have better predictions, tracking, as well as mitigation of WDs. So machine learning models can refine the predictions by identifying the complex patterns in large existing data sets. So interdisciplinary approaches, they can also bridge the gap between the atmospheric science with hydrology, than in agriculture and socio-economics. So this ensures a more comprehensive understanding of WDs and their broader impacts. So based on this review, these are our conclusion. So to conclude, first point, we conclude that WDs plays a crucial role in shaping regional weather patterns. It influences the rainfall, agriculture, water resources, and disaster risk. So their accurate prediction is essential for managing the extreme weather events and minimizing the socio-economic impacts. Although there are an existing models like MM5, WRF, and CMIP5, they have improved WD simulation, but still they are facing the challenges such as biases in precipitation and forecasting, uncertainties in parameterization, and limitations in capturing complex orthographic influences. Then advancements in high resolution modeling refined the cloud microphysics parameterizations. Additionally, integrating AI/ML techniques can enhance WD predictions by identifying the patterns, enhancing data segmentation, better future extraction, and optimizing model outputs. So this would further help to strengthen early warning systems, how they can help in WD predictions. So AI and ML enhance WD forecasting by analyzing vast historical data we can select. Then we can identify the patterns in formation and movement that may improve the detection accuracy. Then deep learning models, they process satellite imagery and numerical data, and they can refine the intensity and precipitation forecast. AI-driven data assimilation optimizations also can be used. They can be optimize the satellite and radar inputs. They improve the model initialization. And additionally, we can also use the ML-based post-processing correct that biases in traditional models and hybrid AI technology can also be integrated with statistical corrections. We may also go for the ensemble forecasting for more reliable predictions. So in future, we can use such techniques to improve the accuracy of prediction of WDs. So these are the few of the references that we refer. Thank you, all of you, for giving us this opportunity. We would like to address any query. My co-author Khushi Shah is also present, so I request to allow her to unmute herself so that we can answer the queries.
Yes, ma'am, please go ahead. Ma'am Aarti, do you have any question?
Yeah, I found this paper is really having this paper is showing your hard work, author's hard work, that they have analyzed so many training models. At the gist, I just want to understand, out of these many models, if I ask you only one technique to go ahead and prove your hypothesis or your objective, which you will go ahead with?
Ma'am, we have gone through the AI/ML integration techniques after performing this review. So that work is also about to complete. Khushi?
But in AI/ML also, what actually you have done?
Yes, ma'am. She'll explain.
But there are so many things which we can
Yes,
show about AI/ML integration.
Hello.
Yes, Khushi.
Yes, ma'am. So we have further developed an entire system based on deep learning and machine learning models. Like, firstly, we have used INSAT 3D satellite data, which is ISRO's satellite imagery data. And along with that, we have used a bitmap data. And then we have implemented certain CNN models and pre-trained architectures to identify the presence of Western disturbances, determine their intensity, and demarcate them using the bounding boxes. And particularly, we found that a unit model performed better for segmentation of WDs from these satellite images.
When you're talking about CNN, so it will not be machine learning, it will be deep learning.
Yes, ma'am.
So, because now if you're talking about, means you are focusing on your data set, but under deep learning also, when you're talking about, again, in CNN, there are so many specifications you have to consider, considering the window size, the number of layers, then the final activation function. So have you given a thought process, or this is a proposed idea? Have you worked on this?
Yes, ma'am. We have worked on this part as well.
So for this particular data set, which activation function you have used?
We used Adam Optimizer.
Okay. Okay. Thank you.
Thank you.
Thank you.
Thank you, ma'am. We'll be proceeding with our last paper presenter for the meeting. I asked for Suyash Koltev with the paper titled Lane Guard, an AI-powered real-time monitoring system for cycle lane violation detection. So if you're ready, then you may go ahead.
Is my screen visible?
Yes, sir, it is visible.
So my name is Suyash Kolte. Our paper ID is 356. So I will present Lane Guard AI-powered cycle lane monitoring, a real-time system designed to detect unauthorized vehicles in cycle lanes using YOLO V8 for object detection and OCR for license plate recognition. The system automates violation tracking and enforcement, improving cycle safety and traffic management. So cycle lane violations are growing issue, making roads unsafe for cyclists. Traditional enforcement methods are inefficient and rely on manual monitoring. Our project proposes an AI-driven solution that detects violation in real time, extracts vehicle details, and assists authorities in issuing penalties by integrating YOLO V8 for detection and OCR for recognition. This system enhances efficiency and accuracy in traffic enforcement. So cyclists face daily risk due to unauthorized vehicles entering cycle lanes. Currently, traffic enforcement relies on manual patrolling, which is time consuming and ineffective. Our project introduces an automated AI-based system that identifies violations instantly. By using deep learning and computer vision, LaneGuard ensures real-time monitoring and efficient violation tracking, reducing the need for manual intervention. So unauthorized parking and driving in cycle lanes cause congestion, increase accident risks, and disrupt traffic flow. Current surveillance system lack real-time detection and require significant human resource. Our solution eliminates these inefficiencies by providing automated violation detection and logging, helping authorities enforce penalties effectively. The primary goal of LaneGuard is to create a fully automated monitoring system that detects violations with high accuracy. Our objectives include real-time vehicle detection, OCR-based license plate recognition, cloud-based violation logging, and automatic notification to authorities. By achieving these goals, we aim to improve cyclist safety and support smart city initiatives. So several studies highlights the effectiveness of YOLO model for object detection, achieving accuracy rates above 91%. OCR models, when combined with image and enhancement techniques, show improved performance in recognizing license plate under varying lighting conditions. These insights have shaped our model selection and optimization strategy. So, LaneGuard integrates real-time video analysis with deep learning to detect cycle lane violations. The system captures live footage, applies YOLO V8 to detect vehicles, extract license plate numbers using OCR, and log the violation in cloud database. Automated alerts and penalties are then issued to violators, ensuring effective enforcement. So our system follows a structured workflow. First, traffic cameras capture video input. The YOLO V8 model identifies vehicles in cycle lanes, and the OCR model extracts license plate details. The violation details are stored in cloud database, and an alert or penalty notification is sent. This approach ensures automated real-time monitoring enforcement. System modules. The system consists of 5 main modules. The input module captures real-time footage. The detection module uses YOLO V8 to identify unauthorized vehicles. The OCR module extracts and verifies license plates. The logging module record violation details, and notification module sends automated alerts to authorities. These modules work together to create a seamless real-time monitoring system. So our project uses deep learning frameworks like YOLO V8, TensorFlow, and PyTorch for object detection. OpenCV is used for image processing, while EasyOCR extracts license plate numbers. The system is hosted on AWS Cloud Services with data stored in MySQL database. The deployment is optimized using edge computing for faster processing. So our methodology begins with video feed input, which is processed frame by frame. The YOLO V8 model scan each frame to detect vehicles. If vehicle is detected in a restricted lane, the bounding box is passed to the OCR module. OCR then reads and extracts the license plate number. We validate the extracted text and log it with relevant metadata. This information is stored in cloud-based database and made available through an admin interface or automated alert system for authorities to review and act upon. To test lane guard, we set up control environment with CCTV cameras monitoring a dedicated cycle lane. We trained our YOLO V8 model using real-time traffic images and tested it on various weather and lightning conditions. The OCR module was fine-tuned with multiple fonts and angles to enhance license plate recognition accuracy. Our project successfully detects cycle lane violations with high accuracy. YOLO V8 was able to detect vehicles with over 90% precision in controlled environment, and OCR showed consistent accuracy in reading standard license plates. The entire pipeline from detection to logging take less than a second per frame. The system performs well in both daylight and low light conditions, demonstrating its robustness and efficiency in real world scenarios. So here you can see a few sample outputs from our system. The system show vehicle that were automatically detected in a red colored cycle lane. The model accurately placed bounding boxes and around the vehicles, and the OCR successfully extracted the license plate numbers. Each violation are logged with timestamp and stored in the database. This example confirmed the effectiveness of our project approach and show how the system works in real time. So LaneGuard provides multiple benefits, including improved cyclist safety, automated law enforcement, reduced manual workload, and better traffic management. It ensures real-time monitoring, making cycle lanes safer and encouraging responsible driving behavior. The system is also scalable for large-scale city implementation. So here we have sample images from our system. Demonstrating its ability to detect unauthorized vehicles and extract license plate numbers. The result confirmed that our AI model works effectively under different uh, conditions, maintaining high accuracy and efficiency in real-time violations. This system can be integrated into smart city infrastructure by connecting with municipal traffic management system. The cloud-based architecture allows easy access to violation reports, and data analytics can help city planners optimize road safety measures. Automated enforcement reduces human intervention, making traffic monitoring more efficient. To further enhance lane guard, we plan to integrate night vision capabilities, extend detection to multiple lane types, and improve OCR accuracy using AI-based enhancements. Additionally, we aim to develop a mobile application for real-time reporting and notification to law enforcement. Like any AI-based system, LaneGuard faces challenges such as variable lighting conditions, occlusion of number plates, and computational cost. Some vehicles may have damaged or dirty license plates affecting OCR accuracy. However, continuous model training and data augmentation can improve system performance. In conclusion, LaneGuard provides an AI-driven real-time solution for cycle lane monitoring by integrating YOLO V8 for detection and OCR for plate recognition. We ensure high accuracy and automation in traffic enforcement. This system can be scaled for smart city applications, improving overall traffic management and cyclist safety. And these are the references research paper that we have referred for our project. Questions? And our co-author Kedar Kulkarni is also present in the meeting.
Any questions?
Hi, Suesh.
Hello, ma'am.
Can I understand instead of using YOLO, you can have hard coded the system. Why specifically with the YOLO?
Ma'am, as a co-author, I would be like to answer this question.
Okay.
Instead of YOLO, YOLO especially detects the car or vehicles. Or instead of yellow, if we train another model, it will be recognizing all objects. Say, if we come to the red color cycle track, it would be detecting the signboards too, or the headlights of the car. The yellow basically used for detection of car only.
Okay, thank you.
Thank you, ma'am.
Thank you, sir. Thank you, ma'am. This brings us to the end of the session. I sincerely thank our authors for the excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 9th version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2026. All the presenters will be getting their digital certificates through email within 2 working days. Furthermore, all the papers have been already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2025. I'd also like to thank our session chairs for chairing the session. A token to the chair on behalf of Team ICTIS 2025 and Global Knowledge Research Foundation. Thank you, Ma'am Aarti.
Thank you very much, ma'am.
I'd also like to thank the session chair. Thank you, ma'am. Yeah. I'd also like to thank a session chair, Professor Priyanka Sharma, for chairing the session. Just before we end the session, I kindly request everyone to turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe and take care.
Thank you. Bye.
Thank you.
Just bye.